Okay, class, I'm back again. I realized I made a small mistake with my first problem I did in my last video 5 minutes ago. Let's evaluate this function for when x equals -2. So, here's the first step. F of -2 equals 4 times -2 all squared minus 5 times -2. And that's to be a -6, not a +6. See that minus sign? I got to preserve that. So that should have been a -6. And then I still get 4 times 4 plus 10, but this again, that's a -6. And then I get 16 plus 10 minus 6. 16 plus 10 is 26, minus 6 is 20. So the output is 20. Or as an ordered pair, that would become now -2, comma 20. Or as a table of values, -2, 20. Okay, so that was the small mistake I made in my last video. And now I might as well do a whole new problem here. So let's try looking at this review problem. It's an inequality, and I see absolute value bars. So my first thought is, oh, it's going to be one of those three theorems. And which theorem is it? Well, it's the greater than sign. So I remember the theorem that we're going to use here. Let me write down the theorem. Theorem. Let's write TH for theorem. And it's going to be this. If the absolute value of some expression, we'll call it u, is greater than some number, which I'll call the variable a, this is how you handle it. So you're right, u is greater than a. So notice how similar that is to the original problem, except you lose the bars. Or, says the theorem, u is less than -a. So notice then for that other part, you switch the inequality sign and you multiply that number by -1. So that's the theorem. That's your template. Whenever you have this idea, an absolute value bars with a greater than sign, think of this theorem and that will lead you to the promised land. So let's go over here. Notice with this problem, I'm not quite ready to use that theorem. Notice with the theorem, it's bare bones. You just have to have the absolute value term by itself is greater than some number. So let's do some legwork first, and then we'll jump into the theorem. So let's first get rid of that loose term. Subtract 10 from both sides of the inequality sign, the greater than sign. Inequalities are very similar to equations or equal signs. I'm going to use the subtraction principle of equality. So that works with inequalities as well as with equal signs, equations. So subtracting 10 from both sides, I get this. 3 times 2x minus 5 is greater than 8. So I've got that. Now, it's still not bare bones. I got to get rid of that 3. So let's divide both sides by 3 next. The division principle of equality. So that gives me this. 2x minus 5. The absolute value of that is greater than 8/3. So notice I divided both sides by 3. Now, doesn't that look like that right there? It's bare bones. The absolute value term by itself is greater than some number. So now let's jump into this theorem. And that will be our answer, or at least a good part of it. So let's do the theorem. So it goes like this. You write it without the bars. 2x minus 5 is greater than 8/3. See how similar that is to that original, except without the bars? Or, and then I write without the bars, 2x minus 5, and then I flip this sign to less than and multiply that number by -1. So I've got that for the other one. Let me step back so you can see all the steps in order here. So here's the original problem. Step 1 was to subtract 10 from both sides, which gave us this. And then the next step is to divide both sides by that 3. So we have this. Now we're ready to use the theorem. So all I did was write that without the bars. And then and then write that without the bars. Flip that inequality sign and then multiply that by -1. So we're going to get like 2 different answers here. And now we'll just solve each one. Add 5 to both sides next. So I get 2x is greater than 8/3 plus 5. What's another name for 5 with the common denominator of 3. How about 15 over 3? Do we feel comfortable with that? Adding 5 to both sides. Isn't 15 thirds the same thing as 5? If you don't see that, let me, I think you guys all see that. Okay, and then let's continue. 2x is greater than 23 thirds. Notice how we add up fractions with the same denominator. Add up the numerators and keep the denominator the same. And then divide both sides by 2, a positive 2. So we get x is greater than 23 thirds divided by 2. That's a complex fraction. Don't leave it like that. Let me do this. 20 little sidebar here. What's 23 thirds divided by 2? Notice I changed the notation. Just makes it more friendly. Same idea. That fractional bar means divide. How do we know how to divide fractions? Isn't that going to be write down the first fraction, 23 thirds, change the divide to times, and take the reciprocal of the second fraction. And then we know how to multiply fractions. You don't need a common denominator when multiplying fractions. Multiply straight across. Numerator straight across, denominator straight across. So we have that. So I'm going to go over here and then simplify. So we get x is greater than 23/6. That's one answer. And then what's the other answer going to be? Let's go back to here, or that one. So then we want to solve this one for x. So add 5 to both sides. So that gives me 2x is less than, what's a negative 8 thirds plus 5? Again, I'm going to call 5 15 thirds, so I get that common denominator. And doesn't that equal 7 thirds? So I'm going to write 7 thirds right here. And then divide both sides by 2, and then we get x is less than, what's 7 thirds divided by 2? Divided by 2 is the same thing as times 1/2, times its reciprocal. And that equals 7/6. And there's the two answers, there and there. Okay. Let me write that in interval notation. So low to high. X is less than 7/6. So that means negative infinity, comma, 7/6. Comma, 7/6. Union, x is greater than 23/6. 23/6, comma, infinity. So there's the answer in interval notation. Let me step back so you can see it all. Maybe you want to pause it so you can look at all that work. All right, good night, everybody.